Hello everybody, this is Ramesh Phani. In this video, we can talk about radicals and radical function. 4 square root of 11 plus 8 square root of 11. In this radical expression, the radicand 11 and here radicand 11 are equal. The index 2, here also index 2, so they are like radicals. Radicals with same index and same radicand are like radicals. Because these are like radicals, so we can add them. 4 plus 8 times square root of 11 equal to 12 times square root of 11. Let us see some other example. 5 times cube root of 3x minus 7 times cube root of 3x. In this radical expression, the radicand 3x and here also the radicand 3x. The index for this expression is 3. Here also the index for the expression is 3. So these two are like radicals, so we can subtract them, which is equal to 5 minus 7 times cube root of 3x, which is equal to minus 2 times cube root of 3x. Let us see some other example. 4 times square root of 5 plus 4 times cube root of 5. Here in this expression, square root of 5 has radicand 5, the index is 2, and in cube root of 5, radicand is 5, index is 3. So in this expression, both the radicands are same, but the index are different, so they are not like radicals, so we cannot add them. Square root of 20 plus 2 times square root of 45. First, find the factors of 20 and 45. This can be written as square root of 4 times 5 plus 2 times square root of 9 times 5. By using the product rule of radicals, we have square root of 4 times square root of 5 plus 2 times square root of 9 times square root of 5. By simplifying the square root of 4, we have 2 times square root of 5 plus 2 times square root of 9 is 3 times square root of 5, which equals to 2 times square root of 5 plus 6 times square root of 5. Now this radical expression, the radicals are same radicand 5 and same index 2, so they are like radicals, so we can add them. So we have 2 plus 6, 8 times square root of 5. Let us see some other example. cube root of 54 minus 5 times cube root of 16 plus cube root of 2. 54, the radicands can be written as 27 times 2. By using the product rule, we can write cube root of 27 times cube root of 2. In this radical, 5 times cube root of 16, 16 can be written as 8 times 2. By using the product rule, we have 5 times cube root of 8 times cube root of 2 plus cube root of 2. By simplifying cube root of 27, we have 3 times cube root of 2 minus 5 times 2 times cube root of 2 plus cube root of 2. 3 times cube root of 2 minus 5 times 2 is 10 times cube root of 2 plus cube root of 2. Now in this radical expression, the radicands are 2 and index also 3, which are equal, so they are like radicals. We can add them and subtract them. So by simplifying, we have minus 6 times cube root of 2. Let us multiply square root of 3 times 5 plus square root of 30, which is equal square root of 3 times 5, multiply this radical with each term in the parenthesis, so which equals square root of 3 times 5 plus square root of 3 times square root of 30. So we have 5 times square root of 3 plus, under one radical sign we can write the product 3 times 30 because their index is same. So we have 5 times square root of 3 plus this radicand 3 times 30 can be written as square root of 3 times 10. So we have 5 times square root of 3 plus the square root of 9 is 3 times square root of 10. Because the radicands are not equal, so we cannot add them further. Let us see some other example. 7 square root of x plus 5 times 3 square root of x minus square root of 5. By using the FOIL method, we have 7 square root of x times 3 times square root of x minus 7 square root of x times square root of 5 plus 5 times 3 times square root of x minus 5 times square root of 5. By simplifying, we have 7 times 3, 21, square root of x times square root of x is x minus 7 times. Here in this radical expression, they have same index, so we can write under one radical sign as a product of 5x plus 5 times 3 is 15 square root of x minus 5 square root of 5. So in this radical expression, the radicals are not like radicals, so we cannot add or subtract further. The expression square root of 3 over square root of 2 can be written as equivalent expression square root of 6 over 2. The denominator has without radical sign is called rationalizing the denominator. Similarly, square root of 3 over square root of 2 can be written as an equivalent expression 3 over square root of 6. Here the numerator has no radical sign is called rationalizing the numerator. The expression a plus b times a minus b, these two expressions are called conjugates of each other, whose product is a square minus b square. To rationalize the denominator, square root of 3 minus 2, we have to multiply the conjugate square root of 3 plus 2 with the numerator and square root of 3 plus 2 with the denominator. Now here the denominator, the two expressions are sum and difference of two terms, square root of 3 and 2. We know the sum and difference of two terms a and b equal to a square minus b square. So we have square root of 3 square minus 2 square. So we have 5 times square root of 3 plus 2 over square root of 3 square equal to 3 minus 2 square is 4. So we have 5 times square root of 3 plus 2 over 3 minus 4 equal to minus 1. So we have the denominator as without the radical sign, so it has been rationalized. So we have minus 5 times square root of 3 plus 2 or minus 5 times square root of 3 minus 5 times 2, which is minus 10. To rationalize the numerator square root of x plus 2, we have to multiply its conjugate square root of x minus 2 with the numerator and square root of x minus 2 with the denominator. Now the expression square root of x plus 2 and square root of x minus 2 are the product of sum and difference of two terms square root of x and 2. We know the sum and difference of and their product equal to a square minus b square. So we have square root of x square minus 2 square over 5 times square root of x minus 2. So square root of x square, by simplifying, we have x minus 2 square is 4 over 5 times square root of x minus 2. Here the numerator has no radical sign, so it has been rationalized. Thank you.